Good morning, pre-calc. Today we're going to talk about right triangle trigonometry. And in a right triangle, if we're given an angle, which we'll call theta, there's an opposite side, an adjacent side, and a hypotenuse. And here's what it looks like. Here's our angle down here, theta. And if we look straight across, opposite side is straight across, has no contact with the sides of the triangle that form the angle. Here's our right angle. The hypotenuse is always across from that. And then that leaves our adjacent side, which is connected to the angle. There are three trig ratios for any angle of theta. And you might have heard of SOHCAHTOA, the Indian that discovered trigonometry. Okay, sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent. So SOHCAHTOA is a way you can remember the three trig functions. And again, trig is just one side of a triangle divided by another. So you need to be able to label your triangle sides, opposite, adjacent, and hypotenuse. And you need to know these three trig functions in order to be able to solve problems in right triangles. There's also three other trig functions, which are the reciprocals of sine, cosine, and tangent. Cotangent, you just flip tangent. Okay, it's going to be adjacent over hypotenuse, or 1 over tangent. It's the reciprocal. Secant, you flip cosine, so it's hypotenuse over adjacent, or 1 over cosine. And cosecant is hypotenuse over opposite, or flip sine, and it's 1 over sine. So tangent and cotangent go together, secant and cosine go together, cosecant and sine go together. They're reciprocals of each other. So here we're going to use this triangle and we're going to find all 6 trig ratios for this angle. So we're looking at this angle right here, and we need to label our triangle. Well, this side's going to be the opposite. This side's going to be the adjacent, and over here we have hypotenuse. Okay. Well, in order to find all 6 trig functions, we need all 3 sides of the triangle. So to do that, we're going to use a form of the Pythagorean theorem, which is the hypotenuse squared equals opposite squared plus adjacent squared. We plug in what we know. We know the opposite is 6. We know the adjacent is 8. 6 squared plus 8 squared is 100. If we take the square root, we get 10. So the hypotenuse is 10. So now we're going to use those 3 sides, and we're going to find our 6 trig functions. So sine is opposite over hypotenuse. So we look at our triangle. Opposite was 6, hypotenuse was 10. 6 over 10 reduces to 3 over 5. Cosine is adjacent over hypotenuse. The adjacent was 8, the hypotenuse was 10. That simplifies to 4 over 5. Tangent is opposite over adjacent. That's 6 over 8, and it reduces to 3 over 4. Once you have those three, all you have to do is flip those to get the other three, cosecant, secant, and cotangent. So if I flip 3 over 5, I get 5 over 3. If I flip cosine 4 over 5, I get 5 over 4. And cotangent will be the reciprocal of 3/4, which is 4 over 3. Okay. Next one. Pause the video and see if you guys can label this triangle, find the third side by Pythagorean theorem, and find the 6 trig functions. Go ahead and pause now, come back when you're done, and we'll go over it. Okay, so we need to label our triangle first. Here's our angle. There's our right angle. This has to be the hypotenuse. This has to be opposite. This has to be adjacent. So if we plug in the two that we know, 2 squared plus 4 squared, that is the hypotenuse equals square root of 20, which simplified is 2 root 5. And don't forget how we simplify radicals. One of them has to be a perfect square. The biggest perfect square you can think of is a factor of 20, and that would be 4. Square root of 4 is 2, and we leave the square root of 5. So let's figure out the 3 basic trig functions. Sine is opposite over hypotenuse. Opposite was 2, hypotenuse is 2 root 5. If we simplify this, we get 1 over root 5. But remember, we cannot leave a radical in the denominator of a fraction, so we got to multiply by the conjugate. And when we do, we get root 5 over 5. Cosecant is the reciprocal of sine, so if I flip that one, and it's easier to flip 1 over root 5 than it is to flip 2 over 2 root 5, because I've already got it simplified. And root 5 over 1 is just root 5. Cosine is adjacent over hypotenuse, so that's 4 over 2 root 5. If I simplify that, I get 2 over root 5. And if I multiply by the conjugate, I'll get 2 root 5 over 5. Secant is the reciprocal of cosine, so all I need to do is flip one of these, and it's easier if I flip this one. That way I don't have to do any simplification, and I'll have my answer, root 5 over 2. Tangent is opposite over adjacent, 2 over 4, which is a half. If I flip that, I get cotangent. So you flip 1 over 2, you get 2 over 1. Number 3, they give us some information here. They tell us that sine equals 3 over 4. They don't give us a triangle, but we can draw our own. Sine of an angle, we'll make this our angle, is 3 over 4. Well, sine is opposite over hypotenuse. So the opposite of this angle should be 3, and the hypotenuse should be 4. So it's easy to draw. Oops. So if I plug in the numbers and figure out what my adjacent side is, remember hypotenuse squared equals opposite squared plus adjacent squared. Hypotenuse is 4, opposite is 3, and I need the adjacent. So 16, 9, subtract 9 from 16, and I get 7. Take the square root. I get square root of 7 for the adjacent. Okay. So now I have all 3 sides. I can flip sine and get cosecant. It's 4 over 3. Cosine is adjacent over hypotenuse. So that is square root of 7 over 4. If I flip that one, I get 4 over root 7 and multiply by the conjugate. I get 4 root 7 over 7. Last one's tangent and cotangent. Tangent's opposite over adjacent. I get 3 over root 7. Got to multiply by the conjugate. I get 3 root 7 over 7. To get cotangent, if I just flip 3 over root 7, I'll have my answer. Root 7 over 3. All right, number 4. I'm given cosecant. I know if I have cosecant, I can get the reciprocal of cosecant, which is sine. So I just flip it. I get sine equals 5 over 6. Sine is opposite over hypotenuse. So I draw a triangle that's labeled with opposite side 5, hypotenuse 6. And I've got to come up with my other side. Hypotenuse is 6. Opposite is 5. I need the adjacent. Subtract 25 from both sides. I get 11 equals adjacent squared. Take the square root. And I have an adjacent side of square root of 11. So to get cosine, I would do adjacent divided by hypotenuse. That's square root of 11 divided by 6. To get the reciprocal of cosine, I flip it and multiply by the conjugate, and I'll get 6 root 11 over 11. Tangent is opposite over adjacent. That's 5 over root 11. I need to multiply by the conjugate to get rid of the radical in the denominator, and I get 5 root 11 over 11. Cotangent, if I just flip the 5 over root 11, I'll have my cotangent. Okay. Next type of problem you may see, I'm given sine of 30 degrees is 1/2, and cosine of 30 degrees is square root of 3 over 2. I need to find tangent of 60 and cotangent of 60. So I need to draw a triangle. Remember that for my sine, this is opposite over hypotenuse. Cosine is adjacent over hypotenuse. So it looks like my hypotenuse is 2, my opposite is 1, my adjacent is 3. So I label it like that with the 30-degree angle. Remember, we're dealing with right triangles, so there's my right angle. If this angle is 30, that means this angle over here has to be 60. So now I need to find the tangent of 60. So looking from this angle, from this 60 degrees, this side is now opposite. This side is adjacent. This is my hypotenuse. So you're always looking from the angle that they give you to label the triangle. So tangent is opposite over adjacent. That's root 3 over 1, which is root 3. Cotangent of 60, I just flip the root 3 over 1 and multiply by the conjugate, and I get root 3 over 3. All right, next one. We are given tangent of an angle is 3. So remember, tangent is opposite over adjacent. So I draw myself a triangle, and I'll list opposite over adjacent. Opposite, adjacent. I need to find my hypotenuse. So it's hypotenuse squared equals opposite squared plus adjacent squared. Don't know my hypotenuse. My opposite is 3. My adjacent is 1. This equals 10. And if I take the square root, I get square root of 10. So I now have all 3 sides. And they want me to find cosine. Cosine is adjacent over hypotenuse. That's 1 over root 10. Remember, you got to multiply by the conjugate. And I get root 10 over 10. You really don't have to write the 1. It's understood to be 1 out front. Cotangent is the reciprocal of tangent. Well, they told us tangent was 3 over 1. So if I flip that, I get 1/3. Then I have to find tangent of 90 minus theta. Well, 90 minus theta is this angle right here. Okay? So I need to switch my opposite and adjacent because I'm now looking from this angle. So when I do that, this becomes opposite. This one becomes adjacent. Hypotenuse stays the same. Okay, so we're like that now. So the tangent of that angle is opposite divided by adjacent, and it's 1/3. Just a quick review of the special right triangles. There's 2 of them. We have a 45, 45, 90. And the ratio of side lengths, the 2 legs are both the same. They're both 1. The hypotenuse is square root of 2. For a 30, 60, 90, the excuse me, short leg is 1. This is the short leg. Long leg is square root of 3, and the hypotenuse is 2. So if we use those as opposite, adjacent, and hypotenuse, I can figure out all these angles here. And these are all angles that you might see on the unit circle. Sine of 45, sine's opposite over hypotenuse. Okay. Opposite in this one is 1. Hypotenuse is square root of 2. So that equals square root of 2 over 2. Cosine's adjacent over hypotenuse, that's also 1 over square root of 2, or square root of 2 over 2. Tangent of 45 is opposite over adjacent. So we have opposite divided by adjacent. 1 divided by 1 is 1. So tangent of 45 should be 1. Sine of 30, same thing, but we're using the 30, 60, 90. Opposite over hypotenuse, you get 1/2. Cosine's adjacent over hypotenuse, we'll end up with square root of 3 over 2. And if we divide those two, 1/2 divided by square root of 3 over 2, or doing tangent opposite over adjacent, we get square root of 3 over 3 once we multiply by the conjugate. Sine of 60, we get square root of 3 over 2. Cosine of 60, we get 1/2. Notice how that these two just switch places because they're opposite angles in a right triangle. The tangent's going to be the reciprocal of the tangent in 30 degrees, or square root of 3. Multiple ways to get answers for the same trig function of an angle. All right, let's look at an example of the type of problem you may see. We have a right triangle that has a 30-degree angle. The adjacent side is 75. The opposite side is x. They don't give us hypotenuse because we don't need it. I know the trig function that has opposite and adjacent in it is tangent. So I'm going to find the tangent of 30 degrees, which is the angle they gave us. Tangent's opposite over adjacent. And now I basically just have a proportion. Let me write it a little neater so you can tell what we have. So there's our proportion. And remember, when you have a proportion, that's two ratios that are separated by an equal sign. You can cross multiply. So if we cross multiply, I'll get 1 times x, that's going to equal x. And 75 times tangent of 30. We can also do it this way. I can figure out what tangent of 30 is and plug that in for tangent of 30 and then cross multiply. Either way, we'll come out with an answer that's correct. Let me tell you the difference. If you work it this way, you're going to need to put this in a calculator and get a decimal answer. If you work it the other way, you're going to get an exact answer, which is 25 root 3. So please be aware that some multiple choice tests may have, you wanting to find the exact answer, which is 25 root 3. Some may be decimals, which you can plug into the calculator. Next one, we have a 45, 45, 90. Hypotenuse is x. Opposite is 20. Sine of 45, we've already looked that up. Opposite over hypotenuse is 20 over x. Sine of 45 is square root of 2 over 2. Cross multiply, we get x times square root of 2 equals 40. And if we take 40 and divide by root 2 and multiply by the conjugate, we get 20 root 2. There's a few other trig identities that we can look at here. One I've already mentioned, tangent is just sine divided by cosine. Well, if you flip that one, you get cotangent because cotangent is the reciprocal of tangent. If I flip sine over cosine, I get cosine over sine. We've already used the Pythagorean theorem. And if we divide the Pythagorean theorem either by opposite squared or by adjacent squared or by hypotenuse squared, we get 3 other trig functions. Let me show you how this works with one of them. If I divide by opposite squared on all of these, opposite squared divided by opposite squared is 1. Got my plus sign. Adjacent divided by opposite, that's the reciprocal of tangent, which is cotangent. Got cotangent squared. Hypotenuse squared over opposite squared is the reciprocal of sine, which is secant. Secant squared. That's this one down here. Whoops. Yeah. That one down there. Nope. The one below it. This one. Should be cosecant here. Sorry about that. Should be cosecant right there. And then if we came back and divided by adjacent squared, we would get another one. Hypotenuse squared, we would get another one. But these are the other 3 trig functions. I advise you to memorize these. This one right here will be the most used. This is known as the Pythagorean identity. Sine squared plus cosine squared equals 1. The next two, not so much used, but are very helpful. Tangent squared plus 1 equals secant squared. And the third one, cotangent squared plus 1 equals cosecant squared. So my advice to you is to write all these identities down on some note cards or a sheet and memorize them. Here's how we're going to use them. What they want us to do with this problem is to verify that cosecant theta times secant theta equals 1. Well, in order to do that, we have to use those identities. The easiest thing to do is to convert everything to sine, some form of sine and cosine. Well, I know secant is a reciprocal for one of those three major trig functions. Secant is the reciprocal for cosine, so secant equals 1 over cosine. Since we're multiplying, this is really over 1. These cosecants cancel each other out. And I have 1 divided by 1, which is 1. So it checks. 1 equals 1. I'm good. Here we have cotangent times secant equals cosecant. Get everything to some form of sine and cosine. I know cotangent's a reciprocal of tangent, which is cosine over sine. And I know secant's a reciprocal for one of them, and it's 1 over cosine. The cosines cancel. We have 1 over sine, which is cosecant. So cosecant equals cosecant. That's what we need. This will get easier as you learn all of the identities. Next one, we have secant theta plus tangent theta equals secant theta minus tangent theta equals 1. Well, this is like having x plus 1 times x minus 1. You can look at it that way. You've multiplied two binomials together before. So let's do that. Secant times secant is secant squared. That's the first ones. Then we have secant times tangent, which is a negative, and secant times tangent, which is a positive. And then we have tangent times tangent, which is tangent squared. What happens is you got a positive here and a negative here. They cancel each other out. So we end up with secant squared theta minus tangent squared theta. So we trimmed it down a little bit. And we want to substitute something for these two. Well, I know tangent squared, if I move that over to the other side, that'll get rid of this negative tangent squared. And I have something that in my identities told me that tangent squared theta plus 1, tangent squared theta plus 1 is secant squared. And secant squared theta equals secant squared theta. We got one more here. We've got negative sine theta plus cosecant theta, all divided by sine theta, equal to cotangent theta. So what we can do here is we can split this one into two fractions because they have a common denominator. Okay. We got negative sine theta over sine theta, and we got cosecant theta, which is 1 over sine divided by sine theta. So secant theta here is 1 over sine. I know negative sine theta over sine theta gives me negative 1. If I do the math here, I get 1 over sine squared. One over sine squared theta is cosecant squared theta. If I move the 1 to the other side, I'm adding it. And my identities tell me that cotangent squared theta plus 1 equals cosecant squared theta. We'll get a lot more practice on those, and you'll see a lot more of these in the next unit also. Okay, here's the type of real world problems you'll run into. We have a 35-foot rope that's tied to the top of a flagpole. If the angle the rope forms with the ground is 44 degrees, about how tall is the flagpole? Well, we're looking for the height of the flagpole, which you hope is perpendicular. Here's the angle of the ground, flagpole to the ground, 44 degrees, and the rope is 35 feet long. I know that if I look from this 44-degree angle, this side's opposite, and this side should be hypotenuse. Well, I know I've got to use sine to figure this out. Sine of the angle, 44 degrees, equals x over 35, opposite over hypotenuse. I cross multiply. Here's a shortcut for you. If the variable's on top, we multiply. 35 times sine of 44. Make sure your calculator is in degree mode. 35 sine 44 is 24.3 feet tall. So it's okay to have a decimal answer for this. That's it for today. Please stay on the Zoom meeting if you have any questions. Appreciate it. Have a good day.